welcome to today's Femmegineering event. So I'm just going to go to the program for today. So we're going to start off with another Get Moving class from Specific Strong from 4 o'clock to 5 o'clock. Then from 5 o'clock to 5:15, there will be a small break. Remember to drink water, stay hydrated. That's very important. And then from 5:15 to 5:45, we will be having an interview with Prof. Andre Grobler regarding electrical engineering. And then from 5:45 to 6:15, we will have an automation of movement interview with Dr. Henry about mechatronic engineering. And then from 6:15 to 7:15, we will have a Q&A session where you can ask your questions in the YouTube chat. So we look forward to your questions. You are welcome to think of your questions throughout the entire Femmegineering event. If we, for example, miss your question, if you don't ask it in the Q&A session, and before the Q&A session, just remind us in the Q&A session time, and then we will answer your question. All right, so good luck and enjoy the Get Moving class.
Hello ladies, welcome to your second Pilates class. I hope you've enjoyed your first one. Let's get going. Okay, so we'll be standing in the middle of our mats. My feet are hip width apart. I am standing nice and tall, wide shoulders. I'm pulling in my belly button and I'm lifting up my arms shoulder height. Okay, be careful not to go up to shoulders. We tend to do this. So shoulders down. And now we do calf raises. So lift up your toes, spread them out, plant them into the floor, and we go up onto our toes and down. Open up the feet, go up onto our toes and down. Toes together and up. And we continue like this. Feet to the front, open up, feet in, and 3. Feet out, toes in, and 4. Keep stretching out your arms, up, toes in, to the front, 5, and open up, pull in your belly button, 6, up. You can also squeeze your bum, toes together, to the front, and 7, 8, feel the calves burning, open up, feel your ankles adjusting to the changes, and up, and toes in, last one, feet forward, I'm moving off from the mat, toes in, and relax. Keep your arms like that, hopefully you should start feeling your shoulders. I am lifting up my arms above my head. Top of my hands are touching and arms down. I'm standing with slightly bent knees, just for comfort's sake. I'm pulling in my belly button, up, and arms go wide. My arms are long. I try to keep my shoulders down as my arms go up, and 5 more, and down. 4 more, and down. Pull in your belly button, try to scoop. 3, remember pulling in the tailbone. 2, and 1. Keep your arms shoulder height. Let's move the arms in, lift them up. Drop them to the front, open up. Same thing, 2. Lift up and down. You can see I try to keep my shoulders down as I lift up my arms. I keep my belly button pulled in. And up. Can you feel your arms working, your shoulders working? And up, nice strong, straight arms, strong hands. Up. 5 more. Up. And 3, and 2. I'm keeping my shoulders down. open. Let's drop the left arm, lift up the right arm, side bend over to the left, look down over your shoulder, keep the weight in both legs, lift up the arm goes up, side bend over to the right, look over your shoulder, lift up again over to the left, look down, pull in your belly button, and up, switch, down. Last one, up, and over. I'm pulling in my belly button. And keep your arms shoulder height. Pull them towards the back. Grab hold of your arms behind your back. And let's pull up our arms. Just stretching the fronts of your shoulders. Small pulses. And relax. Okay, now we can stand at the back of our mats, ready to do our roll down. So remember, knees slightly bent. You can pull in your belly button, scoop your pelvis, pull your head back, chin to chest, round your shoulders, and one vertebra at a time, you round your back. Feel the stretch as you go down. My arms are heavy, my shoulders are heavy. I'm just relaxing, trying to shift your weight backwards, try to keep it above your feet. And again, let's swing around our legs. Around and relax. Start twisting and turning your wrists for me. Get them moving. We're going down on our wrists. Okay, put your hands down. If you have to bend your knees, you can do that. Let's go ahead and bend it all the way. And up. And 2. Up. 3. 4. As you straighten your legs, press your heels into the floor. 3 more. And 2 more. And 1 more. See how you're lengthening your hammies. Now lean forward and start walking on your hands into your straight arm plank position. Okay, hands underneath your shoulders. I'm pulling in my scoop, pulling my shoulders back. We're going to inhale, and as we exhale, push your bum up and back. Hold it there. Tailbone goes up towards the ceiling. Inhale, and we move forward. As we exhale, pull in your scoop, pull your shoulders back, lengthen your neck. Inhale, exhale. Inhale, exhale, get your scoop back, strong shoulders, pull them back. Inhale, exhale. As you go back, try to deepen your stretch. Inhale, exhale. Last one. Inhale, exhale. And we drop our knees, flatten our feet, sit back into your rest position. Try to keep your arms close to your ears, straighten them out. Feel a stretch in your shoulders. Right, up onto our hands and our knees, all fours position. I want you to step forward with your right foot and place it on the outside of your right hand. Right, this is what we call a fascia movement, okay? I'm not going to elaborate on the whole fascia thing, just know that it's like a flowy, stretchy movement. It's really good for loosening up tight muscles, tight fascia. Alright, you can Google it. Okay, so we lean forward with our weight over our right foot, and we lean back towards the left heel without lifting our toes. Let's go forward and back. 3 and back. 4. As you go back in my hip flexor. Let's breathe. 5 more. 4 more. And 3. And 2. Last one. Let's keep our weight in the middle, between our 2 legs. I want you to shift your weight onto your right leg and your right arm. You rotate your body towards the left and you stretch up with your left arm, looking at the ceiling. Use your right elbow to push it into the rotation against your leg and bring the arm down. Let's switch arms. The right arm up. It's easier this way around. Open up as far as you can. And down. Left arm up. And down. Oh, feel the lovely rotational stretch. Open up with your right arm. Let's do one more. Left arm up. Look at your hand. And down. Right arm up. And open. And down. Okay. Slide that foot backwards. And let's do with the left leg. Left leg forward. Put your left foot on the outside of your left hand. 90-degree bent knee. And shift the weight forward. Or feel it in the right hip flexor. And sit backwards, keeping your toes flat. Or down. 2. And back. And 3. Feel the stretch in the hammy as you go down. Back. We're working on the glide of the hammy. The glide of the fascia. If you want to know more about fascia, you can just contact me. I think that would be the easiest. And forward and back. 5 more. 4 more. Really feel the stretch as you go back. And 2. And 1. And let's stay in the middle. Weight between our 2 legs. Keep your weight on your left hand and your left leg. You can push your left elbow into your left leg. Lift up your right arm. Reach up towards the ceiling. Look at your hand. Oh, feel the rotational stretch. And go down. Let's switch arms. Left arm up. Easier this way around. And back. Right arm up. Reach for the ceiling. And back. Left arm. And back. Third one. And down. And up. Bring your arm down. Take your leg back. And let's just sit back into our rest position. And breathe. Some say this is their favorite position. And we're up on our hands and our knees. Okay, so again, if your wrists start hurting, you can go onto your elbows. And if your knees are sensitive for your hard surface, maybe you have a thinner mat, you can either fold your mat or quickly get a pillow to place underneath your one knee. We'll be balancing on the one knee. Okay, so hands underneath your shoulders or elbows underneath your shoulders. Option 1 and option 2. Now, I have my scoop. I am activating my core. I'm pulling in my belly button. And I'm gliding my left leg back. Some of you know this exercise. We are doing it super controlled. Right hand goes forward. Alright. So I'm still keeping them on the floor. I have a strong left shoulder. I'm not sinking into my shoulder. I'm activating my glute and I'm lifting up my leg and my arm. Without falling into my lower back. Keep the core activated. And touch the floor. Let's lift up inhale 2 and down, and 3 and down. Without opening up your hips, 4 and 5. Keep your stomach muscles pulled in, 6 and 7. Don't let your head hang, pick up your head, 8, 9, and let's keep the arm and the leg up. Open them up towards the sides and back. And 2 and 3, 4. Feel how your right glute is working. 6, your left shoulder. 7, 8. Keep the height in your arm and your leg. 9, last 1, 10. Drop the arm and the leg, pull them in quickly. Relieve the pressure from your wrist and relax. Phew. Okay, so take your time with this one. It's a balancing thing. Balance comes from your core. That's right. Keep that pulled in. Other side. So we start by gliding out the right leg. Getting comfortable with the weight on our left knee and hip. Point your toes. Left leg up, left arm out. Pull in your belly button and let's lift up. 1 and down. A slight pause at the top. 2. Exhale down. 3. Keeping your hips closed. 4. And feel it in your right glute. 5. As you lift up your leg. 6. I have strong fingers in my right hand. 7. I'm using my hand. 9 and 10. Keep it up there. Open up to the sides. 1 and back. 2. Don't let your head hang. 3, 4. Your head is in line with your spine. 6. Keep the height. 7, 8 and 9. Last one, 10. Drop your hand, drop your leg, and sit back into your rest position. Okay, so we get up onto our hands and we go lie down on our stomachs for some more back extension work. Alright, so our arms are going to be in a capital E position. Capital E position, this. Okay, so on your stomach you'll be lying like this. Remember to pull the shoulders away from your ears. We'll be lifting up our arms and dropping down. For the second part of the exercise, we'll be using our upper backs as well. And then for the third part, we'll be straightening out our arms. Alright, so what I'll guide you through. I'll guide you through it. So, I'm resting my forehead on the mat, pulling in my chin. My arms are in a capital E position. I'm pulling my shoulders away from my ears. And remember to use the muscles between your shoulder blades to do the lifting. Alright, so arms, elbows in line with the shoulders, and we start by lifting up our arms. 1 and down. 2 and down. 3. If you feel uncomfortable with your head on the floor, you can lift up your face a little bit from the floor. 4. 5. Just use your shoulder blade muscles to do the lifting. 7. 8. 9. 10. Keep it there. Now we lift off our chest. 1. We lift up our chest. 2. Inhale up. 3. Remember to activate your stomach muscles. 5. 6. Inhale 7, exhale down. 8, 9. Let's stay up there. Arms go up. 1, pull them in. 2, and in. 3, 4, keep looking down on in front of you. 5, 6, 7, this is a hard one. 8, 9, last one. 10, and drop your hands. Use them to push yourself up and back into rest position, into that back flexion. And just breathe. Okay. Now we turn onto our sides. I want you to bend your knees and we're on our elbow. Okay, but keep your knees in line with your body. So not in front like this, in line. Make sure your elbow is underneath your shoulder. If it's there, you'll hurt your shoulder. Same here. Alright, so underneath. Let's lift up the right arm, or the other arm that's in the air, depends on which side you're on. And we can scoop in this position, squeeze our glutes, our bum, and we just lift up the hips and we go down. I want you to feel your obliques. Alright, obliques and down. 3, also squeezing the bum muscles. 4, 5, knees in line with your hips and your shoulders. 7, you're going to feel your shoulder working as well. 9, and let's stay there. Now we lift up the top leg. 1 and down. So it's a glute, oblique, and a glute. Keep it in line with your body. Squeeze your bum. 5, 6, 7, 8, 9, 10. Keep it there. Lift up the hip. Lift up the hip. 3, 4, 5, 6. Keep the height of your top leg. 8, 9, 10. And we go down and relax. Well done. So the oblique, the lower part of your, well, in this case the lower abs, but the side of your stomach. Alright, and your bum, both of them, and your shoulder. Okay, next exercise, stay on this side. You have your legs straight out now in line with your body. You can flex your feet. You can use your hand for balance, but don't depend on your hand too much. We are lifting up the top leg, then bending the knee, opening up the knee. Straighten up our leg and bend and glide it out again. Glute exercise. 2, kick up, bend and in. Keep your abdominals activated. 3, 4, kick a hole in the ceiling. 5, up. 6, up. Well done. And 7. You can't straighten out your leg, it's fine. You just go as far as you can go. 9. Last one. 10. And relax your leg. You should have felt the glute of the top leg while lifting up, pushing over. Grab hold of your ankle. Put your foot in front of your hips. Knee up towards the ceiling and just open up your knee. As we are opening up, you can feel your glutes stretching. Open up, open up. And glide back. Let's push ourselves back up. Swing over to the other side. Start with our bent knees. Bent knees. Gebuigde knieën. Knees in line with your hips. Remember, activate scoop. Squeeze your glutes. Arms up, arm up, elbow underneath your shoulder. And we lift up. You should feel your obliques activating. And down. Lift 2 and down. 3, 4 and 5, 6. Keep on squeezing your bum. 7. Pulling in your belly button. 8, 9. Keep it up there. Let's lift up the top leg. 1, 2. Keep the knee in line with the body. 4, 5. Squeeze your bum, especially the lower one. 7, 8, 9. Look in front of you. 10. Keep it there. Lift up the hips. 1, 2, 3, 4. It's burning. 6, 7, 8, 9, 10. Drop and relax. Straighten out the legs and breathe. Flex your feet. You can use your hands to balance, but also activate your core. Let's bend the knee, pull in the knee, kick the heel up and back, kick it out. Let's go 2 and up, pull the knee in, back, 3, up, and 4. Just go in the range where your hip feels comfortable. And 6, even if you have to make the movement smaller, it's fine. 7, pace yourself. 8, and 9. Last one. 10. Up and out. Grab hold of your ankle, pull your foot closer, and let's just bounce the knee outwards. Feel the stretch in your glute. Okay, and relax. For the next exercise, we lie on our back. Okay, so on our backs, lift up your arms towards the ceiling, palms facing each other. Remember, pull in the belly button and push your lower back into the floor. The aim of the game is to keep your imprint, hold your imprint. Let's lift up our one leg, lift up the other one, knees together. Still keeping your imprint. And now let's toe tap. The 90-degree leg goes down and I switch. Still trying to pull in the belly button. Keep your knees 90 degrees bent. Reaching your arms up towards the ceiling. And 5, and 4, 3, 2, and 1. Knees together, pull them in. Okay, so you're not supposed to feel lower back. Really try to hold your imprint. Use your stomach muscles, especially the lower ones. Okay, next exercise. Legs go back into tabletop, nice 90-degree angle, knee above your hips. My arms go back, palms facing the ceiling. Okay, important, pull in the belly button, lift up your arms, your head and your chest. And my arms are parallel to the floor. Stay up in my chest here. I only bring my arms back and then I drop my head and my shoulders. Inhale, exhale, 2 and up. Now don't go relaxing when you're down there. Inhale, exhale, 3. Reach out, try to touch something in front of you, lift yourself up higher. Only the arms go back and up. Arms back. And 6. And back. 7. And back. 8. Exhale. 9. Last one. 10. Let's stay up there. Try to straighten out your legs. Pulse your arms up and down. 1. 2. Lift up higher. Keep breathing. Legs as straight as you can manage. Pull in your belly button. 5, 4, 3, 2, 1, and relax. Just breathe. Well done, oh my goodness. Legs down. Okay. Doing our pelvic curl again. This time we're doing something else. Not switching up the legs. Let's go up with our arms. Now remember, there's a fist width apart between your knees and your feet. A comfortable distance from your bum, so you can lift up. So remember, grip the floor with your feet. Push your lower back into the ground. Squeeze your glutes. Lift up your tailbone, then your lower back, then your middle back, and up. Are you still gripping the floor, pressing in your big toe? And we are lifting up the heels and down. Try to lift them up straight. Are they falling out towards the side? 3 and 4. Squeeze your bum. Careful to not let your knees fall open to the side. And 6, 7. Reach up towards the ceiling with your arms. 9 and 10. Drop your heels. You should not feel your lower back. If you do, try to pull in. Squeeze your bum. And now we lift up the front foot. Toes up and down. 2, 3 and 4. Squeeze your bum. 5 and 6 and 7 and 8, 9. Last one, 10. Keep the toes up. Drop your arms towards the back. Stretch out your arms. Lift up your hips higher. And then as we go down, one vertebra at a time, scoop, scoop, scoop your pelvis. Feel a stretch in your lower back and relax. Bring your arms up. Alright, let's do the inner thigh and the inner glute muscle. So, open up your knees. If this is too uncomfortable for your hips, you can keep your feet flat and just open up as far as is comfortable. Alright, otherwise, foot soles together. Right, same thing. You're just going to use your glutes a little bit more. Imprint, squeeze your bum, and lift up as high as you can. Can you feel your inner thighs? Squeeze your glutes. And let's go down. And lift up 2. And down. Pressing your heels into each other. 3. And down. And 4. Is your core activated? And 5. And 6. Squeeze your glutes. Feel your inner thighs. And 8. Nice and straight arms. Keep it there. 10. Small pulses up. 1, 2. Squeeze your glutes. 4, 5, 6, 7, 8, 9, 10. Keep it up there. Drop your arms towards the back. And roll down. One vertebra at a time. And relax. Bring up your arms. Close your knees. Drop your arms. Pull them in. Did you feel your inner thighs? En die benefit van die bout. Daai binneste boutspiertjie. Inner upper glute thigh. Oh yes. Well done. Okay. Let's straighten out the right leg, flex your foot, intertwine your hands, and hands behind your back. Head. This is your head, behind your head. Alright, so now option 1 is you're lifting up the straight leg, and option 2, you can lift up your bent knee. Okay, so in the first session, we did alternating bent knees. Now we're doing 10 with the one leg and then 10 with the other one. Flex your foot, alright, and we lift up in our chest lift as I lift my straight leg and I turn towards my leg. If it's bent, it would be like this, and you drop. And if it's straight, let's go. 2, and drop. It's lift and rotate and lift some more. It's not just falling over to the right side. 4, and down. And 5, you should feel your right obliques. 6, you're turning towards the leg that's straight or in the air. And 8, and 9, and let's hold, without your pelvis tilting. Now point your foot and flex, point and flex, and I'm feeling my oblique, I'm feeling my quad. Breathe, lift up higher, don't close up your elbows, up and back. 5, 4, 3, lift up higher, 2, 1, and drop the leg. And switch legs. Left leg up into tabletop. You either keep it bent or you straighten. Flex your foot. Let's start there, down there. And we lift up. Rotate towards the left leg without closing up. And down. Exhale. 2. My hips aren't falling over to the side. 3. And 4. It is lifting and twisting and lifting. 5. Feeling it in the left oblique. 6. 7. And 8. And 9. And let's keep it there. And we go point and flex. 2, 3, 4. Pull in your belly button. 7, 8, 9, 10, and relax. Bring your arms down to your side and lie on your back. Okay, so straighten out your legs, lift up your arms and go back. Remember our roll up, squeezing your ankles. And the trick of the roll up is to really get your lower back into the mat at the in position where you actually go up. That's the tricky part. Okay, if you struggle to do this, you might have a tight lower back. So lift up, or weak abdominals, but yes. Lift up the arms, your head and your chest, and use your breath. Exhale, and up, and lean forward again. Over, flex your feet, grab hold of your toes or just your shins, and then stretch it out. I want you to bend the one knee, then bend the other one, alternating your knees, your bending knees. Straightening out, pulling yourself down, and breathe. And now we cross over our hands. Remember which one is the top arm, and again switch, switch, switch. You can allow your hips to go with the movement. Feel it stretching all the way into your hips and your hands. And change arms. Other arm is over. And bend and straighten. you to glide your hands on the mat, fingers facing forward, and lift up your chest. Open up your shoulders. Open up your chest. Feel the stretch in your front arm and your shoulders. Glide forward and reach for your feet. Again, lift up. Open up your chest. Stretch your shoulders. If you don't feel it, go further away with your hands. And glide forward, grab hold of your feet. Pull in your chin, head towards your knees. Last one. Open up, chest out, and forward. And relax. Okay, let's bend, let's say, the left leg. Okay, so you might know this sit position. One leg is bent, the right leg is straight. I want you to reach either down for your leg or your foot and press your right ear against your right arm. And use your left hand to press your left knee away from you, locking your elbow. See, my arm is straight and I can feel it stretching in my lower back. Hold it, hold it, hold it. And we bring the arm over, cover your left ear with your left arm. Now it's directly into the lower back. And now we rotate our chest towards our knee and up again. And rotate down 2 and up and 3. Feel how you're rotating your rib cage from your hips. Last one, grab hold of your foot with both hands. I want you to have a tight grip, either your leg or your foot, and pull away from your foot as if you're pulling back. Then you open up your shoulder blades and you feel your upper back stretching. Pulling away from your foot, like you're fighting the foot. And relax. Let's switch legs. Right knee is bent. Grab hold of your leg or your foot with your left hand, your left foot. Put your left ear on your left shoulder. I'm taking my right hand and I'm pressing down on my right knee. Locking my elbow. Feeling the stretch in my lower back. Breathe. And bring the right arm over, cover your right ear, directly into your lower back now. And return down towards the knee and open up your chest. Rotate your rib cage 2, open up. And 3, and up. 4, open up. Last one, 5. Grab hold with both hands. And pull yourself away from your foot, opening up your upper back between your shoulder blades. Breathe. And up. Okay, butterfly stretch. You might know this one. Feet soles together, grab hold of your feet. Sit up straight. As you sit up straight and you lean back, you can feel your upper back stretching, your upper traps in your neck, especially when you pull in your chin to make a double chin. Show me your double chin. Feel the stretch. And bend your elbows, pull your head forward. You can use your elbows to press against your knees to open up your knees and feel your inner thighs. Hold it, hold it. chin. Find your zen. And pull yourself forward again. You can press down onto your knees. Feel your inner thighs. And relax. Let's sit cross-legged. If you are uncomfortable with this position, make your legs straight as a knot. Make it straighten out your legs. Okay, cross-legged, sit upright like this. Let's glide out the one hand, side bend over with the other one. And lift up. Throw the other arm over. And side bend. Just breathe. We are almost done with your second session. I hope you've enjoyed Pilates. Enjoying moving your body. Feeling strong, sometimes not so strong. Just moving and breathing. Moving and breathing. And intertwine your hands behind your back. Open up your shoulders. You can press your hands into the floor. And open up, stretching your shoulders. And relax. Let's turn onto our hands and knees. I want you to tuck your toes and sit back onto your heels to stretch your toes. Stretch your feet. And now we go sit back onto your heels. See if you can balance there. Just stretch your Achilles heel, your calf. And drop the knees again. Stretch your feet. Stretch your toes. Heels back. And forward. And back. Now bring in your hands closer to your feet, chin to chest, and straighten out the legs, pressing your bum towards the ceiling. Legs as straight as you can manage. Keep it there, bend the one knee, then the other one. Okay, so now you're going to start by brushing the floor with your arms. And then you go, brush. 1, 2, 3, bend, lift up, reach for the ceiling, open up. And we go down. 1, 2, 3, lift up again. Open up, exhale. And 1, 2, 3, big breath in. Open up. Last one. 1, 2, 3. Keep your hands up. Try to touch your fingertips without looking. Ooh. And palms together. And namaste. I'm joking. This is not yoga. Goodbye. I hope you've enjoyed your Pilates classes.
Good afternoon, Professor Andre. You are at the Faculty of Engineering at Electrical Engineering. Can you please just introduce yourself and what you do at the faculty quickly?
Hi, everybody. I'm the program manager for electrical engineering. And I also teach a few subjects, electrical design in third year at the moment. So I'm involved with teaching and also some of the program management activities.
Okay, just a quick fun question. Can you describe yourself in 5 adjectives?
Yeah, that's a difficult one. I wrote a few down here. So I think one is curiosity. I'm very curious. I'm dependable. In Afrikaans, I don't know if you've got it in English, but there's ants in the pants. I've got some roemira. I'm always looking for something to do, and that means that I've got many hobbies. So that's maybe lots of hobbies. And then I like finding the simplest solution to a problem because I think that's the best. I think that's 4, but I think that's enough.
Yeah, that's enough. It's 4 good ones. So quickly, can you describe to us what is an electrical and electronical engineer?
Well, it's only the base engineer. So that's what it is. An electrical engineer, electronic engineer, or the heavy current engineering. We are more concerned with the larger equipment and larger currents than computer engineers. So electrical engineers are involved with electrical distribution and power supply in large systems like towns or shopping malls or whole power systems, for instance.
Can you tell us why is electrical and electronic engineering a combined degree and not separate electrical and electronic?
That's a good question, and I think it boils down to, or it comes from the fact that these two are quite interwoven, and in the world that we live in, electrical engineering is very intertwined with electronic engineering. So it also gives our students a much broader space in which they can work, where they can find employment, and the skills that they gain from these two degrees really complement each other.
What can students expect from the first year in studying electrical and electronic engineering?
Well, there's a lot of the base of engineering as a broad topic is built on physics and built on maths. So all of the physics and maths and science kind of subjects that you need to understand the subjects that follow, that base will be built on in your first year. There's also a few electrical or engineering specific subjects like mechanical drawings, subjects on computer programming and embedded programming as well.
What career opportunities, in your opinion, are there for electrical engineers?
I think electrical engineers can really work in a vast, broad variety of places. From your large state-owned enterprises like Eskom, Telkom, Transnet, Sasol, all of those really big industries, all the mining industries, then also the large renewable space that we're moving into. So all of the renewable power generators, power installers, also smaller contractors or consulting work where every mall and every large building requires some electrical design. Even going smaller into application specific kind of things. So things like robots or manufacturing facilities, these all have power requirements and electrical power design. Going into the electronic side, it's even smaller currents. Some of our graduates work at places like Netstar, designing tracking systems, or telecommunication systems where you've got telecommunication base that is quite far away from electrical supply. So maybe there's a solar system powering that and battery backup system. All of these are examples where electronic engineers could work.
How would you define a successful student?
I think a successful student is one that passes his subjects. Yeah, I think that's the nice thing about studying at the Northwest University. Engineering is a very busy course, so there's lots of class, but that doesn't mean that there's not time to do other things. And the campus and student life is such that if you've got a specific hobby or a specific love for something, you'll find other people sharing that here, and you'll find people that wants to do that with you. So I think as people, we should try to be balanced, and as I said, I've got lots of hobbies from plants and music and art, and I think that's something that we see a lot, that a lot of engineers have a lot of interests, and it's good to bring those together. But to be a successful engineer, a successful student, you need to really work hard while you're busy with your subjects and in class and with the stuff you need to do at home. So finding a balance, but realizing that engineering is a degree that will ask a lot of your time.
Okay, and what are the specialization fields in electrical and electronic engineering? It almost touches on the career opportunities.
Yeah, I think the specialization has to do with where you work or where you want to work. Another example of our graduates is working in the automotive industry, working at places like Volkswagen and Audi, even working in Germany. So if these specific guys had a passion for the automotive industry, and they would work in automation, which is a large part of automotive industry, where you've got robots or assembly lines, stuff like that. So that could be one of the specializations. Depending on where you want to work, I think the larger, more mainstream ones would be power distribution and power generation, as well as heavy machinery, electrical machines, including transformers, large transformers, and also electric motors, all the water we use, all the electricity that's generated in South Africa is some kind of electrical machine. So those are the more heavy current things. Then in the electronic space, you'll be moving more to embedded design or embedded circuit design, which are the small circuits that power equipment, or that gives you some kind of functionality, like the router in your home providing your internet, or your cell phone motherboard, cell phone charger, stuff like that.
What is your favorite aspect of being a lecturer?
I think it's spending time with people and having them kind of getting that concept, or seeing the thing they're learning, the theory, actually having some value, and getting through that, because I look at it as myself and the students are in a combined effort for them to understand the work. It's we have a curriculum, and we have some stuff that we need to understand together. And I think for me, it's really nice when you get these guys and they come from a place where they don't understand something, and they now understand something. It's also nice to realize and to know that the guys that we are developing here and helping with stuff will really make an impact in the world. We electrical engineers keep the lights on. We keep the country functioning, and it's really quite a big task on all of our students. If you graduate, you need to really plow back into this country and do make it great. We've been the state and every taxpayer has been supporting you for 12 plus 15, 17, how many years it took you from grade 1 or grade R to graduating. And I think it's really nice for me to see guys being adding to the country, and also being really enthusiastic and really interested in the things they're busy with. Getting you really get guys that also get excited about the stuff that's taught in the subjects. Not everyone. I think it's also true that you do get some subjects that are really resonating, really interesting to some guys, and some that aren't. And I think that's also part of realizing that in the world there's going to be so many things that you can be interested in or not. So and it's nice to work with young people and see the potential that there is.
Thanks. Do you believe there's some sort of pattern or formula to becoming a successful engineer?
Well, to complete your degree, I think you need to have your bum on the seat. It's a question of putting in the time. Engineering, if you've got the prerequisites in terms of school subjects, then you can complete your engineering degree. It's about making the choices to spend the time and put in the work to get the knowledge that you need, and get the skills that you need, and then to finish that. And for some people that takes a little bit longer, but I think the pattern would be hard work. And I reckon that's the same for being a student and being an engineer in general. If you work hard and you are diligent but also dependable, and realize that you only have a name, people associate you with the things that you do and how you do them, and you are what you do. If you are dependable, if you're on time, if you are hardworking, then it's not something that just changes overnight from being a student to being a graduate. And I think that's the thing that engineering professionals also needs to be: hardworking and dependable and ethical as well.
Great answer, especially the ethical. So I have two end of questions that's not applicable to engineering, but who is your favorite superhero?
It's also there's been, I come from the time when superheroes were like, you had Batman. That was almost like Batman or Superman. But I'm more a Batman guy than a Superman guy. I've really, and I think most engineers like the Iron Man is kind of speaking, and Batman in a sense as well. It's the gadgets that make the hero. It's not kind of some kind of kryptonite or some kind of super duper stuff. I also enjoy the Ant-Man and that's also a nice one. So I think between those three.
And if you could switch lives with someone for a day, who would you choose?
Yeah, I said, you see, I saw you said someone, and I thought if it was something, I would choose my cat, because my cat is just losing the day away in the winter time. A person, I don't really know. I think being on the International Space Station would give you quite an interesting view on the world, literally and figuratively. It would give you some kind of perception that you don't really have from down here. And I think it's something that being an astronaut, it could seem very glorious, but I think it's really hard and lonely work as well. But I think that would be quite interesting to see the world from outer space for a day.
Yeah, luckily it's only for a day, so you won't get lonely. Thank you very much for the interview. I'm sure our listeners gain some insight in what electrical engineering is and how this may affect their choices on what to study. Thank you for participating, and we hope to work with you again.
Thank you very much.
Welcome, everybody. We are here today with Dr. Henry Marais. Dr. Marais, can you quickly tell us what is your role in the Faculty of Engineering?
Good morning, Sane. Yes, I'm the undergraduate program manager for computer and electronic engineering, and then also our new mechatronic engineering program. And I'm also responsible for all short courses that runs throughout our school.
Okay, just a quick fun question. Can you describe yourself in 5 adjectives?
Just 5. I'd say passionate, inquisitive, technical, inventive, and let's go with the fun one, brainy.
Okay, the reason Andre only gave us 4, but I'm glad we have 5 now. Can you tell us what is a mechatronic engineer?
A mechatronic engineer is a specialist engineer that applies computing technology and electronics to the world of mechanics to control things. So typically, mechatronic engineers are the guys who's responsible for automating factories and that sort of thing.
Okay, and mechatronic is a new field of engineering offered at the NWU. What makes this field different from mechanical and electronic engineering?
I think that's an important question. What makes it different is that there's a common preconception that mechatronics engineering is sort of a combination of mechanical and electronic or electrical engineering. And that's it. It's a 50-50 kind of blend. In actual fact, it's a speciality in its own right. So although there's elements of electronic engineering and mechanical engineering at play, the fundamental core tenet of mechatronic engineering is the combination or the application of computing technology in a mechanical domain, specifically with an eye towards the automation of processes. So the mechatronic engineer plays in that space where there's a physical process. You can think about things like controlling mixing of tanks or large industrial bakeries. That would be one aspect. The classical example is a robotic arm that assembles vehicles. So I suppose we've all seen those large robotic arms that build things. That is a mechatronic system. So the mechatronics engineer would be responsible for writing the software code for that arm to be able to do its job. But you will not necessarily find a mechatronic engineer designing the mechanically sound structure of that arm. That is a purely mechanical engineering problem. And mechatronic engineers, we train them to be aware of certain structural challenges, so how strong a mechanical structure would be, but they're not trained as experts in the design of those structures. So as you would know, engineering is sort of a team sport. So you'll have lots of different engineers working on a project, and the mechatronic engineer is the guy who sort of glues it all together.
Okay, and what can students expect from their first year of mechatronic engineering?
At the NWU, our philosophy with regards to first-year engineering courses is to try and keep things homogeneous as far as possible. So for the first year, the computer electronic, electrical electronic, mechatronic, electromechanical, and mechanical degrees are pretty much the same throughout. So you don't need to make a choice necessarily. The first year is, how can we put this? A broad but somewhat boring introduction. So you'll find some math, some physics. There's a module on computer programming. There's also a module on digital electronics. So at least we try and dip in stuff. In semester, there's more maths and more physics, and we add a computer drawing tool, and you start touching on strength of materials and that sort of thing. But fundamentally, the first year is a broad introduction, primarily focused on math and physics with some additional modules in between.
Okay. Are there any exciting projects currently at Mechatronic Engineering?
Well, I suppose since mechatronics is a new thing, the entire mechatronics project is probably exciting, but we've recently spent a few million rand in establishing the mechatronics lab with our industry partners, primarily Siemens. So we have some of the latest Siemens equipment in the lab, and we're looking forward to be releasing a video in the near future detailing what's available in the lab and all the cool stuff we can do with our new laboratory space.
Okay. How do you define a successful student?
I'd say for a successful student, I divide it into three things. So firstly, you need to be passionate about what you are studying. And that does not mean the specific modules in broad terms. So if you want to do engineering, you'll be able to sort of suck up the bad bits and enjoy the good bits. So that on the one hand. You have to be committed. It's pretty tough course. So if you're not really committed towards your studies, you'll find it extremely difficult. And then one thing that I think a lot of people underestimate the value of a good support network in terms of find yourself a group of friends, preferably ones that study engineering that can help you figure out the difficult things. Engineering is pretty much a team sport, so it pays dividends to have some guys to help you through the difficult times, and in return you can do the same.
Okay. What is your favorite aspect of being a lecturer?
Well, I lecture the design module, and that's a pretty difficult one since it's really open-ended. So the favorite bit of that module is probably seeing the degree of inventiveness that students exhibit once you give them a problem and say, well, come up with a solution. And as long as the solution is technically viable, it's correct. So every year I'm amazed at the variation of solutions that students can come up with completely on their own. And I think that speaks towards our quality of teaching in the years leading up to the design model.
Okay. What key activities would you recommend prospective students to invest their time in?
Specifically for mechatronic engineering or in general?
In general, but if they want to study mechatronic as well.
Right. Well, I think in general, I'd say just sort of get your hands dirty with things that's not necessarily of academic value. Engineers create things. We solve problems and it's mainly math and physics, but we create things. So build something, get yourself, even if it's just Lego blocks, just build something. And I think it should be fine if you can cultivate a mindset that it's fine if things are not perfect, but you'll keep going if they go wrong. I think that would be my number one hint. So in a nutshell, just make something.
Okay. So I have two end of questions, just two fun questions. What do you like to do on vacations?
Two things: read a lot, but it has to be paper books and no electronic stuff, and to detox from electronics. So unplug as much as possible from all the digital things that child time relentlessly throughout the year.
If you were a type of food, what type of food would you be?
Yeah, this is a difficult one, but I think I'd have to go with something like a pizza.
Okay. Why would you say you're a pizza?
Well, I think it illustrates that you can sort of with make some interesting combinations of simple things that turn out pretty well.
Okay, cool. Thank you for answering all our questions. I'm sure the students know a bit more about what mechatronic engineering is and a little bit more clearer at what we do at the NWU. Thank you for your time, and we hope you the best in the time working from home. Goodbye.
Hello, everybody. Thank you for joining us for our second live Q&A session. We have a few questions here on our YouTube live chat. Thank you for listening to our electrical engineering and our mechatronic engineering interviews with the lecturers. We're going to answer the questions that you've asked on the chat now. So, Danette, if you can read me the first question.
Okay, so the first question was from Mali Nudia, and she asked, does mechatronic engineers use Python as a programming language?
So, as an engineer, during your studies, you use mainly MATLAB, and that's Python based. But you can also, if you go further into computer and electronic engineering, you also focus on C, C++, and C Sharp. But in general, to have a good knowledge of all the programming languages is beneficial because going into industry, everything these days are being coded.
So the next question is from Diodine Kukumur, and she asks, what kind of drawings can an engineer get?
Okay, Diodine, I think it depends on what engineer are you talking about. For mechanical engineers, this can be physical CAD drawings of buildings of a mechanical component. For electrical engineers, you can have single line diagrams that represents the electrical circuit in a simpler way. And for chemical engineers, you can have the drawings of the processes at a facility or at a manufacturing plant. So the kind of drawings that an engineer get is a lot. You get all of your information from drawings. And if you have a certain component in the main drawing, that component has a more detailed drawing and it goes further and further into more detail. So you can expect a lot of engineering drawings as an engineer.
Yes, so we have another question from Annabelle, and she asks, does mechatronic engineers get hand-on experience or do they only code the system?
Okay, so mechatronic engineers, it depends on if you're talking about while you're studying or while you're working. So in industry, it depends on the industry that you go into. In a consulting industry, you will more focus on developing a product for a person, and there you can maybe work more on a computer and do coding. If you work at a facility, for example, let's say at a car manufacturing facility, you will get hands-on experience on working at the plant. But as a student, you get hands-on experience in our facilities. At our labs, we have a new mechatronic lab, and there you get hands-on experience on how to do this in the industry in the future.
Okay, so then we have a question from Mia Ham, and she says, is mechatronic engineering a good starting point to pursue aeronautical engineering and space flight?
So on the line, we have Professor Liesel van Dijk, and she's going to elaborate more on this question for us.
Thank you for that question. Okay, so the first important thing to know is that we don't have an undergraduate program in aeronautical engineering. Nowhere in the country will you start your undergraduate program in aeronautical engineering. You normally have those type of programs after you have studied your first degree. And the same applies, for example, to biomedical engineering. So those of you interested in biomedical engineering, you first do an undergraduate degree and then you build on it. But to get back to your question, the best program to study if you want to go into aeronautical engineering is mechanical engineering. So you can imagine that mechanical engineers are typically those that design cars, and aeronautical engineers are typically those that design aeroplanes, which is different kind of vehicle. And I must tell you that the Northwest University really has great expertise in terms of aeronautical engineering. For example, some of the lecturers at the school are those who designed some of the sailplanes that's winning international competitions. So the short answer to your question, mechanical engineering is the right program to start with if you would like to become an aeronautical engineer.
Thank you, Prof. Liesel, for that answer for us. I think all of you should feel honored that we have our executive dean with us today here. So we have a next question from Annabelle. do you get to buy AutoCAD while studying for engineering? So, Annabelle, I don't know if you mean if you want to buy AutoCAD for yourself or personal use, but you work with, you can elaborate more, NX, you work with NX Design in your first year. In my years, we used SolidWorks, but they are now using NX. But these programs are available for you at the university as a student, as a registered student. You have access to MATLAB, you have access to NX, and a few other programs that you have access to as a student, as a registered student. When you leave the university, when you're not anymore a registered student, you've graduated, you will lose the student access to the program. So I see any other questions. I'm just going to give a few minutes for you to maybe ask a few more questions. Just give you, I think, 2 minutes, and then we will end this Q&A session. Okay, hello everybody, and we're back. We have a few extra questions. The first question is again from Annabelle. Thank you for all of your questions. We appreciate them. So she asks, is the NX program nearly the same as AutoCAD, or does the program work differently? So we're going to, again, direct this question to Prof. Lisa van Dijk, and then we'll get ask the questions after that.
Thank you, Sanai. They're really using the opportunity to let me work tonight. But it's my privilege, Annabelle. Annabelle, the programs are the same. It's both engineering drawings programs. It has the same purpose. And the same applies to many other of the programs that you will use. There will be other programs, for example, for simulation modeling. You can use either Simulink, or you can use Arena, or you can use this the same purpose for different programs. I think what's important, which I like to share, is that we are not there to teach you to use the programs per se. We are there to teach you the philosophy and the process, the techniques behind programming or behind drawing or behind simulation. So yes, the programs are doing the same thing, and although we will only use one, we will select the most appropriate for the situation. You will be able to use any other programs once you've graduated. So we will teach you the principles so that you can actually use any software to solve that particular problem.
Okay, and thank you, Prof. Liesel, for that answer. Yes, it's just a matter of getting that engineering skills behind you. So we have another question from Queen. So it says, so when it comes to my marks, can I still do engineering even if my maths and physics are around 60%? So the engineering requirements are above 70%, but there's also the additional engineering test that you can also do to get into engineering. And if it depends on where you are now at school. If you're all still, I don't know, Queen, how old are you? You're still in grade 10. I would motivate you to work a little bit harder just to get it to that 70%, because then you will automatically be accepted to engineering and doing all the additional work. But if your marks are around 60% and engineering is your passion, I would recommend just to go for it. Look at all the extra programs that the university offers for you to get into engineering.
Yes, and I would also suggest that if you do not have the marks yet, you can also register for a BSc course in mathematics and physical science. I would suggest that you watch the video of yesterday. Ms. Elsa Harting explained a few ways in which you can enroll in engineering.
And Queen, also remember all of our videos are available after the live stream, and we are going to divide it for you into separate parts so that you don't have to watch all of the 5 hours and search for where you want to focus on. Okay, so we have a few more questions.
So dear Dean asked, what can we expect when we go further in any engineering directions?
Going further, so you have a few options. I'm going to answer this, and I'm going to ask Prof. Liesel also to give her input into this. So there's a few options. After you finish your engineering degree, you can join a graduate program at a big consulting company, and also a lot of the financial industries are taking on engineers to help them with their systems. You can join a structured program as a graduate engineer and work yourself up through that system in a bigger company. Or you can decide to do postgraduate studies to further your knowledge and insight into your engineering field. So to expect after your what to expect after your studies, it's so different depending on what you choose for yourself. And I'm also going to ask Prof. Liesel for some of her insights.
Yeah, maybe what I can also add is that I think we cannot be optimistic that your chances will be good to get a bursary as you go along. I know, I'm quite sure that there was some information provided about bursaries. And then what also often happens is that the company who provides you with the bursary requires that you work a few years after your studies. And that's actually great. It's actually great because they often have graduate programs. So if you have a bursary, it's possible that you will go into a graduate program. Even if you don't have a bursary, it's possible that you can go into a graduate program, and then the company will help you while you're working to gain additional skills. I think it's also important to realize that in the old days, you started to study something, and when you retired, you also were in that profession. But what's very exciting is if you follow the careers of our students, of the people who studied with us, you will see that they go in all kinds of directions. They may start off as a computer engineer, and they will end up as an entrepreneur owner of some company, or they will start off as a mechanical engineer and they will end up as a systems engineer. So I think the short answer is that the choice is yours.
Thank you, Prof. Liesel. I agree with you. The choice is up to yourself, just deciding on what's your passion. So we have another question from Sandri. is if I'm interested in building robotic hands and so on, what exactly should I go study? For building anything robotic, I would suggest you to go study computer and electronic engineering or go study mechatronic engineering, because building robotics is in the electronic side of engineering, and also you shouldn't forget about all the programming that's involved in building robots, etc., because the control of them is very important. So go and do your research about maybe what specific field you want to do, industrial automation, stuff like that. I would prefer or suggest you to go study mechatronic. If you want to go into finer robotics, I would suggest go to study computer and electronic engineering.
Okay, so we have another question from Mia, and she asks, what skills, for example, programming languages, can we start learning in high school to help us in engineering programs?
So I know that the schools offer an IT subject in which you start to learn how to code. I myself studied electrical and electronic engineering, where we had computer coding subjects, but I did not have information technology as a subject on school. So the opportunity for you is there to catch up with the rest if you don't have coding on school. But if you want to start learning a coding language, I would suggest start learning Python, and it would help you go further. And Prof. Lisa also wants to say something, so I'm just going to give her an opportunity.
Maybe something also that you can consider, which you probably didn't expect now for me to say, is to realize that if you want to be an engineer, it's not only about the technical skills, it's also about creativity. So whilst you're in school and you may have the opportunity to do an art course or any form of creative, you see now how creative our students are. That's actually maybe good. Maybe you won't have another opportunity. Even skills like public speaking, even skills like presenting yourselves. Those are skills that any engineer will need. So if you would like to do some additional work to prepare you for your career, maybe don't only restrict it to technical skills.
I also want to add on what Prof. Liesel said. For example, well, I was in school 10 or 11 years ago, but I had visual arts as a subject and not information technology or engineering, graphics and design. I didn't have the engineering subjects. I had the physical science and the mathematics to get into engineering, but my other subjects focused on the more artistic side. So don't put all of your creative talents into a box and say, I'm going to have only technical skills. Incorporate those skills with your technical skills.
Okay, so we have another question from Maria Fulwe, and she asks, is a mechatronics engineer qualified to pursue a career in electrical engineering?
So the course in mechatronic engineering focuses more on the mechanical starting subjects and the electronic and the computer subjects. To be an electrical engineer, you will require some power system subjects that helps you understand how the power system works, and it works at a much higher voltage level. I know it's very technical words that I'm throwing around now here, but it's a different field of engineering. If a mechatronic engineer can make the switch, but it will be a big leap to electrical engineering. The principles of electricity stays the same, but you will have to make a big mind shift to understand the principles of electrical engineering. And that is all of our questions. Thank you, everybody, for all of the questions that you directed for us. It's very focused. I'm very impressed with your questions. I want you to come and study with us. You look like very dedicated students. I'm just going to ask Prof. Liesel, do you have any closing remarks?
It was really a privilege to be with you, and I'm looking forward to meet you in person. That's all from my side.
Okay, thank you, Prof. Liesel, and thank you for joining us tonight. So tomorrow is our last day of live video streaming. So we will start between 4 and 5 with our Get Moving class, again presented by Fit Best Training. This will be a more live class where we will do some dancing. Between 5 and 5:15, we will have a short break just to move the legs around, just stretch a bit and get a glass of water. And then Dr. Teresa Hatting will be joining us in explaining more about industrial engineering. After Dr. Teresa, Dr. Melvin Ferreira will explain computer and electronic engineering to us. And then, last but not the least, we will have Ms. Felicity Bupape explaining chemical engineering to us. What is it about and how to keep the processes moving. After that, we will have again a Q&A session. So if you have any questions, just direct them in the live chat. Even if they're at the start of the industrial engineering video, if you have a question, a thought that comes up, ask it. We monitor the live chat continuously. So thank you, everybody. Thank you for today. I hope you enjoyed everything. We will see you tomorrow.
Bye.